This is a video from the Chapter 6 review in Calculus 2. The directions say to sketch the region enclosed by the given curves and find the area. Let's take a look at problem 3. Suppose we're given y equals the square root of x minus 1 and x minus y equals 1. Okay. Let's draw a picture of what this looks like. I'm going to start with y equals the square root of x minus 1. So here's the y-axis. Here's the x-axis. If I replace x with 1, y is 0. That's right here. If I replace x with 2, my y value is 1. That's right here. And so we get something like this. And this is y equals the square root of x minus 1. Now, let's take a look at x minus y equals 1. If I solve for y, can we agree y equals x minus 1? Well, when x is 0, my y value is negative 1. When x is 1, my y value is 0. Okay? And if I were to draw, I'm going to use red. We get something like this. And the region I'm going to integrate is shaded here. Now, let's draw a rectangle, and I'll use blue to draw my rectangle. So here's my rectangle. I need to know the height, and I need to know the width to find the area. Well, the width is dx. The height will be the top function minus the bottom function. So it's going to be square root of x minus 1 minus x minus 1. Now, from here, we need to find the values of x where these two graphs meet to find my limits of integration. So, to find limits of integral. So I'm going to set x minus 1 equal to the square root of x minus 1. Square both sides. Now, if we're more comfortable, we can square out the left-hand side. And when we square out the left-hand side, we get x squared minus 2x plus 1 on the left side. On the right side, we get x minus 1. Okay? And from here, I'm going to subtract x, add 1, subtract x, add 1. And so we get x squared minus 3x plus 2 equals 0. Factoring the left side, we get x minus 1 times x minus 2 equals 0. So x is 1, or x is 2. Now we're ready to go. So the area is the integral from 1 to 2 of. Now let's take a look at the height. The height was square root of x minus 1 minus the quantity x minus 1. So we get the square root of x minus 1 minus the quantity x minus 1 dx. So this is the integral from 1 to 2 of square root of x minus 1 minus x plus 1 dx. From here, we can integrate. So this is 2/3 times x minus 1 to the 3/2 minus 1/2 x squared plus x evaluated from 1 to 2. And we're in the home stretch because all I have to do is replace x with 2 first. And when I do that, I get 2/3 times 1 minus 1/2 of 2 squared plus 2. And I'm going to subtract the quantity, right? And I'm going to replace x with 1. And so I get 2/3 times 0 minus 1/2 times 1 squared plus 1. Now, 2 squared is 4. 4 divided by 2 is 2, right? So these two terms are going to cancel. And what I get over here is just 2/3. So we'll go to the next page. And we get 2/3 minus. Here, negative 1/2 times 1 squared is negative 1/2. Negative 1/2 plus 1 is 1/2. So I get 2/3 minus 1/2. And the correct answer for problem number 3 is 1/6. Let's take a look at problem 4. So on problem 4, we have y equals sine of x, y equals 1 minus sine x, and x is wedged between 0 and pi. So again, we want to draw a picture of what this looks like. Here's the y-axis. Here's the x-axis here. And I would suggest starting with y equals sine of x. Now, when x is 0, you're at 0. At pi over 2, when x is pi over 2, you're at 1. When x is pi, you're at 0 again. And so it's going to look like this, like a hill. Now, we'll use blue for y equals 1 minus sine x. When x is 0, you're at 1. When x is pi over 2, you're at 0. So it's going to come down here. When x is pi, you're back up to 1. So at pi, we're up here again. So I'm going to come down here, and I'm going to come back up to 1. So it should look something like this. Now, we need to figure out these points of intersection here to get our limits, right? So, to find limits, we're going to set sine of x equal to 1 minus sine of x. So that says sine of x equals 1/2. And when sine of x equals 1/2, we know that x has to be pi over 6 or 5 pi over 6, because remember, we're on the interval 0 to pi. Okay? Now, let's come back here. So we got our limits out of the way. Now we need to figure out the height and width to find the area. So there's the rectangle, right? So what's the height? I'm going to take sine of x and I'm going to subtract, because that's the top function, I'm going to subtract off 1 minus sine of x. And when I simplify, I get 2 sine x minus 1. The width is dx. So the area is the integral from pi over 6 to 5 pi over 6 of the height, 2 sine x minus 1 dx. This is negative 2 cosine x minus x evaluated from pi over 6 to 5 pi over 6. Okay. So I'm going to replace x with 5 pi over 6. And I get negative 2 cosine of 5 pi over 6 minus 5 pi over 6. And I'm going to replace x with pi over 6. And I get negative 2 cosine pi over 6 minus pi over 6. Now, cosine of 5 pi over 6, 5 pi over 6 is in quadrant 2, cosine's negative. And so I'm going to get negative 2 times negative root 3 divided by 2. I'm going to go minus 5 pi over 6. And then distributing the negative, I'm going to get plus 2 times square root of 3 over 2. That's what cosine of pi over 6 is. Plus pi over 6. Now, these 2's cancel. We get square root of 3. Those 2's cancel. Plus square root of 3 minus 4 pi over 6. And so this is 2 square root of 3 minus 2 pi over 3. And that's how we do problem number 4. And that's a good stopping point for this video. This is a video on the Chapter 6 review, and we worked on problems 3 and 4. Okay, thank you.